Most quantitative research is going to contain some type of hypothesis testing or statistical tests. This is when you either have like this situation where you have a supposed mean or a mean from the past, mean or average from the past, or a status quo, and you collect some data either from a subgroup of the population and you want to say that this particular subgroup has a different type of average, whether that's less than, greater than, or different than the average of that's been previously shown, or you want to show that now in this time that average has increased, decreased, or is not the same. And that's what the situation is here. We are going to do a hypothesis test, a t-test, because we do not know the standard deviation of the population. So this is a t-test and it is a one sample t-test. And if you've read this problem, we have a police chief who launched a wellness initiative for his police department, mostly focused on working out and fitness. Hopes that this has led to a healthier lifestyle change in decreasing their donut consumption during their shifts. Before the initiative, we're eating about 12 donuts per shift. And so he's going to record the number of donuts eaten for 25 shifts since that initiative to see if that has decreased. So this is the data that we have for the last 25 shifts. And we're going to do a hypothesis test to see if we can say there's a statistically significant decrease in their donut consumption. I'm going to do this with an online statistical analysis tool called SALT Cengage. It is from Cengage. I am using this as an example for my Intro to Stats students. This is a great user-friendly software for that level. It's probably not what I would use for research or any kind of advanced stats, but it's a really good tool to kind of get the hang of some simple hypotheses tests. Go back to my data. SALT wants a CSV file, so I need to save my data as a CSV. Here it is. The other thing that SALT is going to do is it's going to read this first row as a label for your data. So the format is important that you put the label in row 1 and then a column of your data. If you wanted to do more than one set of data, you could. You would just label another variable and have that column. To save Excel file as a CSV, you go to Save As. In this drop down menu, you want to, in the Save As type, you want to go to the CSV. So mine is like the 5th one down, and I'm just calling it the donut example. And I will save. So now it is in a CSV format, and I can find it and upload it to SALT. So I'll do upload CSV, and it's this first one, the raw data set. And here it is, donut example. And then you select your variable. So you could have multiple ones here if you had had more columns to your data set. We just have the one. Numerical default is good. Select. And now your data is in SALT. To do a hypothesis test, it's under the Inferential Statistics tab. So you'll just click on Inferential Statistics and fill out what you know about your data set. So select your procedure. This is a one sample T because we just have one set of data that we're comparing to in this case, a previous average. Select the correct variable. So again, ours only had the one. This is the mean, standard deviation, and size of our data. It computes this for you. We do want a hypothesis test, and then you enter in your hypothesized mean. This is from your alternative hypothesis, which I should have written in. So our null here, the status quo, I'm going to call it H0, is that the mean of the data is equal to 12. So the mean is equal to 12. And our alternative is he thinks it's decreasing, so that our mean is less than 12. So our hypothesized mean is 12 and our alternative hypothesis is a less than. And then just click generate results and you have your output. And they also write up that hypothesis for you. It's good to just check and make sure that's the same as yours. They give you again the mean standard deviation of your data set. The standard error is the standard deviation considering that this is the average of the sample means. So the standard error is found by the standard deviation divided by the square root of n. Degrees of freedom for the mean is n minus 1. Have our t statistic, and then this is our p-value, the most important thing. So this is the probability that if our null was true, if the average was actually 12, that I'd be able to select a data set that looks like this with this in mean standard deviation. And so that is actually a fairly good probability that I'd be able to select a sample that looks like the sample that I selected. So since that p-value is greater than our threshold, our level of significance, then we cannot reject the null. We fail to reject the null, and we do not have statistically significant evidence to say that the donut consumption has decreased. So here is that conclusion written up for you. You failed to reject the null. The chief was not able to gather enough evidence to reject the null, and there is not sufficient statistically significant evidence to say that donut consumption has decreased. He either needs more data or to try something else and then recollect data to try to get that to decrease or to show that there's been a decrease.